Welcome to The Explainer. So glad you're joining us today because, wow, we are diving into something that beautifully bridges two completely different worlds, hardcore physics and immersive art. We're looking at a totally fascinating recent paper called From Understanding to Resonance, a case study of quantum music and embodied science communication. It was put together by an incredible team of researchers, Kenji Noda, Akira Koga, Stefan Hisler, and Koji Hashimoto. And honestly, what they've mapped out here is basically a paradigm shift in how we teach and share really complex stuff. If you have ever felt totally shut out by a tough subject, just hit a brick wall, the insights we are about to unpack in this explainer are going to be an absolute breath of fresh air. Let's get right into it. Okay, let's dive into this. The paper kicks off by pointing out a massive, super common challenge. How on earth do we actually get people engaged with highly abstract science? I mean, we're talking about fields like quantum physics here. For most of us, these topics just feel incredibly distant, right? They're hyper-technical, buried under layers of complex math, and frankly, they just seem totally inaccessible. And you know what usually happens when communicators try to explain these things? They just double down on the technical jargon. That just builds a taller wall. The audience ends up feeling intimidated or just plain bored. Well, the authors of this paper realize something crucial. If we really want to invite people into these complex worlds, we have to entirely flip the script on how they enter. To really get this shift, we got to look at two totally different models. Over on the left, you've got the traditional explanation-centered way of doing things. You know the drill. Lectures, textbooks, strict formulas. It basically demands that you completely understand the mechanics conceptually before you're allowed to appreciate the subject. But over on the right side, that's the disruptive, resonance-driven method these researchers are championing. Instead of just talking at you, this approach is immersive, it's artistic. It asks a brilliant question. What if you could actually feel the science before you ever had to understand the math? It trades in the chalkboard for sensory experiences, aiming to create a real emotional and physical reaction, a true resonance with the material. So that brings us to Section 1, Festivals of Quantum Art, Case Studies from the International Year of Quantum Science and Technology. Let's see how this played out in the real world. During the International Year of Quantum Science and Technology, these researchers didn't just sit around theorizing. They went out and looked at actual real-world events. And get this, they drew a crowd of 4,000. That's over 4,000 participants across these events, which is just wow, right? Think about how hard it is to get the general public to voluntarily show up for a weekend event about quantum physics. That massive number alone proves right out of the gate that people really do have an appetite for abstract science. You just have to package it in a way that feels welcoming and intriguing, instead of, feeling like a mandatory school exam. So what were these 4,000 people actually doing? Well, the researchers zoomed in on two specific festivals, Quantum Fest in Japan and Quantum 100 in Germany. And let me tell you, both of these completely threw out the traditional rulebook. They leaned incredibly hard into immersive musical experiences, like literally translating quantum mechanics into soundscapes you could hear. They had these stunning visual art installations that gave shape and color to invisible atomic concepts. And the real kicker? Embodied participant engagement. You weren't just standing there passively watching. You were moving, listening, interacting, physically existing in a space that was designed to mimic quantum phenomena. By mashing up sound, sight, and movement, they built entirely new, alternative doorways into the physics. Now, of course, these are scientists we're talking about, so they had to measure whether all this cool art and music actually did anything beyond just being a fun day out. To rigorously evaluate the success here, they pulled together some really robust data. They looked at post-event surveys to catch the broad trends, they dug into direct participant comments to gauge the emotional impact, and they did deep-dive stakeholder interviews with the organizers. By bringing all these data sources together, they were able to look way past the surface-level novelty of these festivals and really pinpoint the underlying psychological mechanisms that made them tick. Now, what's really interesting about this slide is Section 2, 3 Dimensions of Resonance. We are breaking down the impact of immersive science to see exactly why this framework works so well. Okay, so by pulling together all that participant feedback, the researchers figured out exactly why this immersive approach works, and they broke it down into 3 dimensions. The first one is sensory immersion. Think about it. When someone hits you with a wall of complex jargon, your brain instantly throws up defensive barriers. You think, nope, I'm not smart enough for this, or this literally has zero to do with my life. But when you engage the senses, say by letting someone listen to the eerie, beautiful sounds of quantum music, or letting them wander through a massive light installation representing particle waves, those psychological walls just melt away. The intimidation factor is completely gone. Engaging the senses basically bypasses the anxious, over-analytical part of your brain and just lets you experience the wonder of the concept first. It takes something totally inaccessible and makes it intimate. Let's move to and see how this builds into the second dimension, collective meaning-making. Traditional learning can be a pretty isolating experience. It's usually just you sitting alone, staring at a textbook, but at Quantum Fest and Quantum 100, the learning was embodied and it was entirely shared. Participants were moving through these spaces together, reacting to the art side by side, discussing what they were hearing and feeling in real time. The authors discovered that this shared physical presence creates an incredibly powerful dynamic. The audience is forming an understanding together. By making it a collective experience, the huge, daunting task of figuring out quantum physics turns into this fun, communal journey of discovery rather than just an individual struggle. And that naturally flows into the final dimension, transformative engagement. Now, this is where the long-term magic really happens. Because people experience the science physically, through their senses, and because they processed it together with a community, their core relationship to the subject matter actually shifted. They weren't just memorizing a random fact just to forget it the next day. The data showed real, emerging shifts in how people interacted with the science over time. They walked out of those festivals feeling curious, empowered, and personally connected to the scientific world. The engagement was literally transformative. It turned them from passive, intimidated outsiders into active participants who felt they actually had a stake in the world of quantum technology. So the crucial point is right here in Section 3, Beyond Conceptual Understanding. It is definitely time for a rethink on how we communicate science. The authors are making a really strong case here for educators and communicators to broaden their definition of what success looks like. Yes, obviously, conceptual understanding is super important, but it shouldn't always have to be the very first step. I love this quote from the paper. It just perfectly sums up their big breakthrough. Resonance-driven approaches can complement explanation-centered science communication by enabling audiences to form meaningful relationships with science before, alongside, or beyond conceptual understanding. The key word there is complement. They are absolutely not saying we should toss out our textbooks or stop teaching the hard facts. No way. They're saying that building an emotional, sensory relationship with the material is a hugely vital companion to intellectual learning. You can spark that resonance before they ever see an equation right alongside their studies, or even as a way for them to appreciate the science if they never fully master the math. It's all about building that relationship first. And that brings us to our final thought for today. Whether you're a teacher trying to engage a classroom, a professional trying to pitch a really complex idea to a client, or just a lifelong learner trying to tackle a daunting new subject, how could this immersive, resonance-driven approach change the way you do things? What happens if you stop trying to just explain and start trying to create an actual experience? How could art or sound or shared physical spaces help break down the walls in your own life? It's an incredible paradigm shift, and I really, really recommend keeping it in your back pocket the next time you're facing a topic that seems totally impossible to crack. Thanks so much for joining me on this explainer. Keep exploring, keep learning, and we'll see you next time.